Welcome to free energy and equilibrium. So remember that delta G naught and KEQ, which is the equilibrium constant, apply to standard conditions. But delta G, note that there's no naught in this case, and Q, which is the equilibrium quotient, apply to any conditions, including equilibrium conditions or standard conditions. So it's useful then to determine whether substances will react under specific conditions. So we have delta G is equal to delta G naught plus RT times ln Q times the natural log of our reaction, our equilibrium quotient, Q there. So at equilibrium, the reaction quotient Q is equal to KEQ, the equilibrium constant, and delta G is equal to 0 because there's no driving force one direction or the other, and that means that delta G has to be equal to 0. And this means that then this reaction becomes this, where we now replace delta G with 0, and then we can rearrange and get delta G naught by itself. So delta G naught is equal to minus RT times natural log of K. Again, note that going from here to there, we replace Q with K, because at equilibrium, Q is equal to K. So at equilibrium, we can say that Q is equal to K and delta G is equal to 0. So that means that now delta G naught is equal to minus R times T times the natural log of our equilibrium constant, K. And this means that if delta G F, the Gibbs energy of formation, is less than 0, then the equilibrium constant has to be greater than 1. If G, or if the change in Gibbs energy is equal to 0, then the equilibrium constant is equal to 1. And if the change in Gibbs energy is positive or greater than 0, then the value for K has to be less than 1. So that was free energy and